This experiment is about the mole and how we use the mole in chemistry to count very small quantity of material via weighing the material. So in this particular experiment, what you are going to do is do an analogous procedure in which you are going to count volts, beans and rice, and other hardware through the mass of that particular item. Now, to start, what you need to understand is what the mole means. And so let me begin by saying that the mole is really nothing more than a number like a dozen. So if you keep that in mind, it shouldn't be that confusing, albeit a mole is confusing. The mole really is nothing more than 6.02 times 10 to the 23rd. It's a number that represents that many items of quantity, whether you're talking about seconds, grains of sand, pennies, or atoms or molecule. A mole represents that many quantities. So if you keep that in mind, hopefully it won't be too confusing. Now, before I begin to give you, before we talk about this experiment, let me give you some background as far as why the mole is important. If you think about the atomic scale, we measure items in terms of the atoms or the molecules or chemicals, compounds. But in the macroscopic scale, the scale that we know, we measure things in terms of grams. So the question is, how does the two quantity relate to each other? How can we go from the atomic scale to the gram scale, a scale that we can measure? Well, the way we do that is we magnify things. Let me give you an example. Suppose we have one carbon atom. One carbon atom has an atomic mass of 12. Let's say we have the carbon 12 atom. This is the representation. If we weigh that carbon atom, then the mass of that carbon atom at the atomic scale would be 12 AMU. Now, what if we collect many carbon atoms so that we have as much carbon atoms as it'll take to weigh 12 grams? The question is, how many carbon atoms will that take? Similarly, if we have a water molecule, and a water molecule weighs 18 AMU, how many water molecules will it take to weigh 18 grams? Well, we don't have to do this because luckily a scientist by the name of Amadeo Avogadro did this experiment for us. What he did was took carbon atoms and counted these carbon atoms until you got 12 grams. And using his procedure, we can take water molecules, count water molecules until we get 18 grams. And that many carbon atoms or water molecules turns out to be a number that we use today. That number is Avogadro's number, 6.02 times 10 to the 23rd. So, the key to understanding a mole and relating it to the number of atoms to the number of grams is to understand Avogadro's number. So mole really is a way of counting by weighing. Again, let me remind you about how the mole is nothing more than a magnifier. If we consider atoms, molecules, or formula unit, we can take this atomic scale and magnify it to the macroscopic scale and measure the gram quantity of these particular chemical. An atom might be let's say we have a nitrogen atom, nitrogen 15. A molecule might be methane, CH4. A formula unit will be an ionic compound. Ionic compounds are, the chemical formula are said to be formula units. Might be sodium chloride. Now you know that nitrogen 15 has an atomic mass of 15 AMUs. Methane, CH4, has an atomic mass of 12, which comes from carbon, and 4, which comes from the 4 hydrogens, to give you a total of 16 AMUs. And finally, sodium chloride, which has a mass of 23 from sodium and 35.5 from chlorine to come up with 58.5. How many of the nitrogen atoms do we need to weigh 15 grams? How many of the methane molecules do we need to weigh 16 grams? How many of the sodium chloride formula unit to weigh 58.5 grams? Well, that many of each of those chemicals comes out to Avogadro's number, 6.02 times 10 to the 23rd. And we define that quantity as 1 mole. So I really like to define a mole as a magnifier that takes you from the atomic scale to the macroscopic scale. And you can use it in many of the chemical calculations in this lab and in Chapter 7 and Chapter 8. So the question is, how do we use the mole and the molar mass in stoichiometry calculations? Well, before we do that, let me show you how these things are related. In chemistry, the mole is the most essential part in doing chemical calculation. You can always determine the mole of a chemical based on 2 things. Either the mass of that particular chemical, so if I have the mass of chemical A, I can calculate the moles of chemical A. And the relationship between the mass and the mole is the molar mass for chemical A. You can think of it as the conversion factor that takes you from mass of chemical A to moles of chemical A. Now, if chemical A is a molecule, then you would use the molar mass. If chemical A was an atom, then you would use the atomic mass. If chemical A is an ionic substance, then you would use the formula weight. Atomic weight, or atomic mass, molar mass, or molecular weight, or formula weight is nothing more than the sum of the atoms in that particular chemical based on their weight, the weights of the elements. So recall that water has a chemical formula of H2O, 2 hydrogens and 1 oxygen. Each hydrogen weighs 1.2 18.0 according to the periodic table. Each oxygen weighs 16.0 according to the periodic table. So if you add those up, it comes out to 18.0 grams, and that represents 1 mole. Another example is sucrose. Sucrose is nothing more than table sugar. The chemical formula for that is C12H22O11. To figure out the molecular weight of sucrose, you would need to take 12, which is the atomic mass of carbon, multiply it by 12, 144. Add that to the hydrogens. Each hydrogen weighs 1. Multiply that by 22 because we have 22 hydrogens. So that would be 22. So 144 plus 22 would be 166. And then finally, the oxygens. There are 12 oxygens. So 12 times 16, because 16 is the atomic mass of each oxygen. And if you add that up to 166, then you come up with the molar mass of sucrose. In our example here, to get from mass to moles, we use the molar mass, atomic mass, or formula weight. Now, another scheme of getting the moles is the number of particles. If we have X amount of molecules or X amount of atoms, how do we calculate the number of moles it has? Well, we use Avogadro's number. Avogadro's number is the conversion factor that relates items of that particular chemical to moles.